Hi everyone. In this video we are going to discuss about the testing of mean of a population. So we are considering a population and we have a sample based on which we are going to test the mean. So we shall move on to the testing procedure. So the testing of hypothesis concerning the mean of a population, we have the null hypothesis as mu equal to mu naught. So we have to take a decision of whether to accept or reject this null hypothesis based on a random sample. So we have a random sample x1, x2, etc. xn of size n taken from a particular population with its mean as mu and the standard deviation sigma. Actually, we don't know what is this mean. So therefore, we have a testing problem where we assume or where we have the null hypothesis as this mean value is mu naught. So we have to check whether it is true or false. And the standard deviation may be known or may not be known. So there are two cases where either the standard deviation is known or the standard deviation is not known or unknown. And in the previous video, we have discussed what is a large sample and what is a small sample. So here we are going to consider the large sample. So since the sample is said to be large, we take the n to be greater than 30. So the sample size of x1, x2, etc. xn of this random sample is taken to be greater than 30. So now we have to test a hypothesis or the null hypothesis which we have already stated, that is h naught mu equal to mu naught. If we have a null hypothesis, we know we will always have an alternative hypothesis which is there with the null hypothesis. So there are three choices for the alternative hypothesis. What are they? Here the null hypothesis is that mu is equal to mu naught. So mu equal to mu naught is the null hypothesis. So one of my alternative could be mu greater than mu naught. The other one could be mu less than mu naught, or it could be mu not equal to mu naught. So if I am not going to accept this null hypothesis, then I could accept the alternative hypothesis accordingly. So these are the three choices of the alternative hypothesis. As I have already said, it could be greater than mu naught, it could be less than mu naught, or it could be not equal to mu naught, depending on the question we have. Now I have already told that the mean is unknown and therefore we are going to test the mean of a population. But there is another parameter, that is the variance parameter, that is sigma square or the standard deviation sigma. So there are two cases, as I have already said, that sigma is known and sigma is unknown. So we shall first consider what if sigma is known. So suppose sigma is known. So there is only one parameter that is unknown, that is mean. So in that case, the test statistic or a function depending on which we are going to take decision is z is equal to x bar minus mu naught divided by sigma by root n. So x bar can be considered as an unbiased estimator for the mean, and it is considered to be one of the best estimators. So depending on this fact, we are going to define, or we define a test statistic, that is z is equal to x bar minus mu naught divided by sigma by root n. As we know, since this sample is a large sample and there is an approximately normal distribution, or this follows a normal distribution. Even though we are not going to that, this x bar minus mu naught by sigma by root n divided by sigma by root n follows a standard normal distribution when h naught is true. So this is the test statistic when sigma square is known. So the second case is when sigma square is unknown. So when the sigma square is unknown, the test statistic can be written as x bar minus mu naught divided by s by root n. Here S is the root of the sample variance. So since we don't know what the population variance is, we are going to find the variance from the sample which is being replaced. That is, the root of the sample variance is denoted by S. So we can use this instead of sigma. So this is the test statistic. So there is no much change, though when we calculate there is a change, but in the test statistic seemingly there is no change. So now we shall move on to the test procedure, how we shall take a decision depending on this test statistic. So here is a test procedure. So in the test procedure, we shall consider each alternative cases one by one. So in the first one, we have h naught as mu equal to mu naught, which is common for all the cases, versus h1, which is mu greater than mu naught. So suppose we are going to test this h naught, mu equal to mu naught, and we have the alternative as mu greater than mu naught, then how will we take a decision? We shall take a decision if this z value, the tabled value or z value that we are calculating from this test statistic, if it is greater than this z alpha, if that z value is greater than this z alpha, then we will reject the null hypothesis. Similarly, for all the other cases, if the second case h naught mu equal to mu naught versus h1 mu less than mu naught, similarly we reject the null hypothesis if z is less than z alpha. So in the first case, when we reject the null hypothesis if z was greater than z alpha, and in the second case we shall reject h naught if z is less than z alpha. The third case is a two-sided case. That means we have the alternative hypothesis as mu naught equal to mu naught. If the alternative hypothesis is mu naught equal to mu naught, that could be mu could be greater than mu naught or mu could be less than mu naught. So in that case, we take a decision to reject h naught if modulus value of z is greater than or equal to z alpha by 2. So now all of you may have some confusions regarding how to find this z or how to find this z alpha. This z is calculated using this test statistic, and in the test statistic we know everything. We can find x bar because we have the sample. We know what is mu naught, it is given in the question. And either sigma will be known or sigma will be unknown. So we can calculate that value because all the factors in that test statistic is known to us, or we can find it from the sample. Something that is not known or something that is unknown is z alpha and z alpha by 2. So we have told this z follows a standard normal distribution. So we can find this z alpha and z alpha by 2 from the standard normal table. So while discussing about the normal distribution which we have discussed, we have used the standard normal table. So from the standard normal table, we can find the value of z alpha, where alpha is usually taken to be 5% or 1%. So if alpha is equal to 5%, then z alpha is 1.65, and if alpha is equal to 1%, z alpha is 2.33. So that value can be obtained from the standard normal table, and z alpha by 2 can also be obtained from the standard normal table. So we can check whether this z value that we have calculated using the sample, if it is greater than this z alpha, we reject h naught. If it is less than this z alpha, so in the second case we reject h naught, and if the modulus value of z is greater than or equal to z alpha by 2, then we reject h naught in the third case. So this is the test procedure for testing the mean of a population in a large sample test. I hope this video was useful. Thank you.